So there are a few different type of symmetry. I'm gonna talk about it. So, and you might want to write it down. Now, are they gonna test it in AB, BC? No, but I'm still gonna teach you. And okay, so symmetry with respect to the polar axis. So symmetry. I'm sorry. There are two types of symmetry, but it will help you in some situation. I will tell you. Symmetry respect to x-axis, which is also known as the polar axis. Okay, also this polar to x-axis. Basically, how do I know they are symmetry to polar axis? You basically you replace data with negative data. And if you got same equation as before, then they are they are symmetry to x-axis, which is before we didn't have anything with respect to x-axis. We have respect to y-axis, we have respect to origin, we only have those two in terms of even odd functions. So you basically place the data with negative data. Now, with the prerequisite, you have to know certain things, right? What is a certain thing? Sine of negative data is equal to negative sine data. This is called a odd function. And cosine of negative data is equal to what?
Cosine data.
Cosine data, because cosine is even. So this is the prerequisite you need to know. Does that make sense? Now you have another type of symmetry, which is symmetry to y-axis. But in terms of this, we're gonna call that theta equal to pi over 2, which is the y-axis. Now basically you replace r and theta with negative r and negative theta. And if you get back the same result, there's a symmetry to y-axis. So this is, if you get back same result, if the same result is respect to that. Last one is symmetry to origin. And that means you replace the r with negative r. Then you can tell me what kind of symmetry are they. And usually you test in that order, you can see what kind of symmetry are they. Okay, so I'm gonna start with this question. R equal to 1 minus cosine theta. I want you to tell me what kind of symmetry are they. Oh, origin is also called pole. So what kind of symmetry is this? Which is also known as what? Polar axis, right? So 1 minus cosine of negative theta Well, we know cosine of negative data is going to be 1 minus cosine of data. So that is result the same. So this is a polar axis. Okay, so we can replace the second thing with negative r with or r equal to 1 minus cosine theta. We say negative r equal to 1 minus cosine of negative theta. Negative r equal to 1 minus cosine of theta. That's positive. And that r is equal to negative 1 plus cosine theta. It didn't come out the same result, so it's not symmetry to y-axis. So it's symmetry to x-axis, right? And then you say, okay, well, let's replace the r with the negative r. Well, negative r is equal to 1 minus cosine theta. It's not. So r1 equal to cosine theta minus 1. So this is not the same. So the only thing that's work is symmetry to polar axis. So therefore, you can see that. Also, look at this polar axis. So we're going to say r equal to this. R equal to, and we're going to see if it's true. Because if it's true, then you only have the graph halfway. 1 minus cosine theta. Like this. If it's true, then you have the graph halfway. But we can see how they graph it though. Let's check out how they graph. C. Add a slider C between 0 to 2 pi. And this is how I did it. Now, you guys need to learn how to do different things on the calculator. That's a part that you're going to have to do it yourself. So we're going to say less than.
Why do we have to do less than?
Because they can shade the inside. You can see how the things forming. Does that make sense? This is how the areas accumulate. It's each line to the point. Each line, but every line is in terms of the ray from the origin. Does that make sense? You had to do 0 data to see, and then you had to add a slider to see. Okay. With that being said, we're going to start with a slope and tangent line. How do we find dy dx? And we're going to talk about that. And according to the cheat sheet, the dy dx is equal to what? Well, you can look at a dy d data, right? Over dx d data. Right, that's a way to do it. Now, since we know that y is equal to r sine theta and x equal to r cosine theta, can I take a derivative of this and use a product rule? Right, you can use a product rule. And then you can figure out all the stuff. And if I use a product rule, this will look at it's gonna be what? R cosine theta, right? Plus R prime of what? Oh, I'm sorry. This is I did the wrong one. I'm gonna take it to the top. So it'll be R prime sine of theta plus R of cosine theta. Is that okay? And on the x is gonna be R prime of cosine theta minus R sine of theta. So this becomes a longer form of this. Is this okay? Okay, so what I'm gonna do is I'm gonna ask you to find um, r equal to 2 plus 3 sine of theta. I want you to find um, I want you to find all the point. So find all the point where you have um, horizontal tangent. How do you find horizontal tangent? Well, you just need to just dy d theta equal to 0.
Yeah, so you put in each sine of or y of each side.
What'd you get? Which it could get 4 points. What is
Pi over 2, 3 pi over 2, 7 pi over 6, 7 pi over 6.
could be?
What? Mr. A, do we need a calculator?
Why do you need a calculator?
I don't know what angle gives sine of 1/3.
Huh?
What angle gives sine of negative 1/3?
Sine of 1/3. Wait, show me your work. Pi over 2 and 3 pi over 2. Yeah, for sure. I don't know about the other two, Aiden. I don't know the other two.
It's 1 plus 3
Probably.
sine of theta, so sine of theta equals.
Okay,
negative
yeah,
1/3.
only pi over 2 and 3 pi over 2. And the other one, you got to use calculator to figure out. because you cannot find when sine is equal to 1/3. Huh? You cannot because it's not in the unit circle. It's not 1/2.
It's the 1/2, yeah.
Yeah, it's not 1/2. And can you find out where the coordinate is?
Let's find out the coordinate for 3 pi over 2.
Yeah, you had to find out where yeah.
Yeah. That was good job. R is 5 and negative. Oh, we can't do that here.
Okay, so you should be able to take a derivative of this, and so so what is y? Y equal to what? R sine theta, right? So in this case, will be R. You had to plug in the R. What is R? 2 plus 3 sine of theta times sine of theta. Is that okay? And this is y equal to 2 sine theta plus 3 sine squared theta. If I take a dy dt, it's going to be what? 2 cosine theta plus what? 6 sine theta, cosine theta, right? Can I take out cosine theta? And that's equal to 2 plus 6 sine theta. And if dy d theta equal to 0, which is the top part, right? That's the horizontal tangent. If a bottom part is going to be a vertical tangent, is that okay? So then cosine theta is equal to 0, theta is equal to pi over 2, and theta equal to 3 pi over 2. But 2 plus 6 sine of theta, if you really want to find it, is 6 sine theta equal to 2, negative 2, sine theta is equal to negative 2 over 6, which is you have to use calculator to figure out negative 1/3, which is arc sine of, will be theta is equal to arc sine of negative 1/3.
So we're only finding the theta values, we're not finding the points.
You can plug in the theta in a function and to see what R is.
How do you do that for the 2 points?
You have to use calculator. But this one you can plug in here, right?
So there's only 3 points that it would work, not 4?
Huh? Those 4.
There would be 2 points that are
It's not arcsine. It's actually sine theta equal to -1/3. So there are 2 points. If I use arcsine, yeah, arcsine is kind of confusing. So don't use arcsine. But you need to use arcsine to find one value and then add it to the other side. Because there are 2 values, right? So you can plug it back in to figure out what the horizontal tangent is. Is this okay? Now you can also find out dy dx at any data. So I don't know if this one is a good question to do, but I can say, well, I can pick up another point to another question, but I can't find a question right now.
0 to pi over 2, we're not doing the infinite points.
No, we're gonna do 0 to pi 2 pi. So what happened is now we're gonna talk about now sometimes you had to find dy dx, you had to find out dx dt is, and you had to plug in, you had to solve it, but you had to substitute the r. When you substitute the r, then you can find out everything. You can find out dy dx. Now,
so the only way we would be able to find those other 2 points would be to manually like plug it into a function like this, find the zeros, then plug that 0 into the original equation.
Yeah. So for example, let's say
formula.
for example, sine theta equal to -1/3. You can do it on graphing calculator. It'll be slightly easier. So if I ever do that, it'll be sine of x equal to -1/3, right? So it'd be +1/3. So it's gonna happen at 3.48 and 5.94. And if I really want to find it, I can find those 2 values. Okay. Now, how do I find the area? Area is going to be just this equation. Area is equal to 1/2 the low bound of A, B of F of theta squared d theta. And F theta is this is R.
How come it's 1/2?
Okay, so what we're gonna do is we're gonna start by looking at this. And we says, okay, well, let's find out how to find a one paddle. R equal to 3 cosine theta, 3 theta, 3 cosine of 3 theta. So how many paddle is this? 3. If it's odd, then it's gonna be the same amount of paddle. Okay. So how do you find the area of one paddle only?
No, it would be from 0 to wherever the first petal ends, which would be when.
Well, do you know? Here's the thing.
You would take from the first cosine of 3 theta to 0 to the second cosine of 3 theta equals 0.
Why is that?
Because once it reaches 0, that completes the petal.
Okay, that's can you do that?
Yes. Yeah, you should make cosine 3 theta equals 0.
So the same as last.
Do you guys know what he's saying?
Yes.
So because we wanted one petal, every time that you complete a petal, because that value equals 0, that means that cosine of 3 theta has to equal 0, and it reaches that quicker because it's 3 theta. So it makes a petal 3 times faster. So basically it would be whenever cosine is 0, so it'd be pi over 2, but then it's 3 times faster. So that would so 0 to pi over 6, right?
So what you're gonna do is set the r is equal to 0. Why is r equal to 0? Because that's when you reach the pole, right?
Yeah. Oh.
So can I do 0 equal to 3 cosine of 3 theta?
Oh, so you're solving.
I mean, would it be at would it start at 0? Because at 0 it's not going to be 0.
It's not gonna be 0.
Would it be
It's not gonna be 0.
So
Would
it's
it be pi over 6 to pi over 6?
pi, yeah, pi over 6 to
Okay, so what we're gonna do is you're gonna do that. So 0, and this one is gonna be cosine of 3 theta is equal to 0. When is cosine theta equal to 0?
Pi over 2.
Pi over 2?
6.
No, pi over 2 equal to 3 theta, right? And what I'm gonna do is I'm gonna use the other value because I think it's slightly easier. Why is that? Negative pi over 2. You would have worked with anything. You would have worked with anything. So then I can figure out what theta is equal to pi over 6. Does that make sense? Theta is equal to negative pi over 6. So can I just integrate this?
Why are you making it then?
Because there's 2 sides. At the beginning.
You want to get some result. You want to get some result anyway. Okay, now it's math.
Wait. Mr. Dave, why don't you just, instead of using the half, if you, oh wait,
You can do, yeah, you can, instead of do 1/2, you can do 1 between 0 to pi over 6.
is it, you're making a pedal?
That would be half pedal.
That's what I was thinking, and then you could.
Then you had to times 2.
But then what I was gonna say was, is every pedal, like, I don't know, depending on the function, does it always, it's always.
Well, no, because if it was sine, it would start at 0.
So I'm gonna show you here. I'm showing you here.
Yeah,
I'll show you here.
It starts at the top of the pedal. If it's a sine function, it starts at the beginning of the pedal.
I'm gonna show you guys here. That way you guys can see.
A combination.
R equal to 3 cosine theta, right? Cosine theta. 3 theta, so that's 3. Okay, so that's fine. 3 here. And I'm gonna show you that between negative pi over 6 to pi over 6. That way you can see that that's a 1 pedal. And if you want to see how the 1 pedal is formed, then I'm gonna do C, but I'm gonna add a C from 0 to from negative pi over 6 to pi over 6. Do you see that? And if you want to see how the accumulator area is going to be less than equal to. Okay, now just the math. You can do the math. It has some like a little bit tricky integrals. You gotta make sure you can do. Huh? Use power reducing. First of all, do you guys understand why I need to set R equal to 0?
Yes.
Because that's when now. And now. because that radius is equal to 0. Because the r equal to 0. That's the radius equal to 0. That's when it touched the pole.
Oh, the actual. So before you do use sub, it would be from pi.
Mr. Yang, would sine be set equal to 1 or is it also?
What?
Would sine still be equal to 0 as well?
Yes, it would be.
You still find out where the origin, because that's a pedal. You want to figure out when they come back.
It's the top of the What is the
Sine would start out from 0.
It does. Ah, it doesn't work. I did that. Hell yeah. Oh, I'm talking about
Oh.
God, there's a lot of people.
You gotta use double power reducing to figure out this. That's why I told you guys to memorize power reducing.
Wait, what's it? Oh, you was my
My buddy. What are you looking at?
Is this okay so far? Is this okay so far?
Yes.
I just expand them. I'll take out a 9. And what's the power reducing for cosine? 1 plus cosine 2 theta. But in this case, it's 2 theta or what? 6 theta.
Is it over 2 or
Over 2.
Wait. We just did. Wait, what? You for something you did 6 square root. Well, I know the power reducing, but where did the 3 in front go?
Took it
No,
out.
you took it out.
So can I take out a 2?
Hopefully, yeah.
What's in equation 1? Theta plus sine of 6 theta over 6, right? Is this okay? Ria, are you guys paying attention? Do you guys get this far? Okay, good. So can you plug in and tell me the answers?
I want to go back to Kansas.
Do you just use them on like the very beginning?
Use of what?
You did.
Alvin, don't do that. You're gonna do something again.
Use up once.
Wait, what?
I didn't even do use up, to be honest with you.
That's like work.
No. Maybe for you, not for me. My brain's too old for that. You guys got homework today, and today's homework you gotta be very pay attention to the details.
How is it?
I'm gonna have to go run to the office to get it.
Alright. Should I go here? Or?
You should get a launching company.
Only for that. Zero. Equals pi over 2 pi over 6 equals 18 pi over 24, which equals 2 pi over 3 pi over 4. How's it 3 pi over 4? Wouldn't it be 2 pi over 3?
It's 1/3, right? So 2 pi over 6 is pi over 3. So 3 and 9 cancel. It's gonna be 3 pi over 4. Here.
Wait,
Here.
because it's
Hold on.
18.
This is a 6, and this is 3. This is 3, and this 3 and 1.
Yeah, I was
3.
thinking,
It'll be
I was
3
thinking
pi.
it was 16. That's
3
why.
pi over 4.
Okay.
Can you open a door for